Let's now look at how to manage application data. Defining databases schemas for Google Managed Databases, for example, Firebase Firestore, Cloud Spanner, Cloud Bigtable, or Cloud SQL. All the Firebase real-time database data is stored as a JSON object. So when you think of the database as a cloud-hosted JSON tree. Unlike a SQL database, there are no tables or records. When you add the data to the JSON tree, it becomes a node in the existing JSON structure with an associated key. This is generally a hash code. You can provide your own keys such as user IDs or maybe some semantic names, or they can be provided for you by just using a push function. A Cloud Spanner database can contain one or more tables. Tables, they look like relational database tables in that they are structured with rows, columns, and the values, and they contain primary keys. Data in Cloud Spanner is strongly typed. You must define a schema for each database, and that schema must specify the data types of each column of each table. Parent-child table relationships. There are two ways to define the parent-child relationship in Cloud Spanner: table interleaving and the foreign keys. Cloud Spanner's table interleaving is a good choice for many parent-child relationships where the child table's primary key include the parent table's primary key columns. The following general concepts apply to a Bigtable schema design. Bigtable is a key value store, not a relational store. It does not support joins, and transactions are supported only within a single row. Each table has only one index, the row key. There are no secondary indices, and each row key must be a unique one. Rows are stored lexicographically by row key, from the lowest to the highest byte string. Row keys are stored in big endian byte order, sometimes called the network byte order, the binary equivalent of alphabetical order. Column families are not stored in any specific order. Store datasets with similar schemas in the same table rather than in separate tables. In other database systems, you might choose to store data in multiple tables based on the subject and number of columns. In Bigtable, however, it is usually better to store all your data in one big table. You can assign a unique row key prefix to use for each dataset so that Bigtable stores the related data in a contiguous range of rows that you can then query by a row key prefix. Bigtable has a limit of 1000 tables per instance, but in most cases you should have far fewer tables than that. Creating many small tables in a Bigtable anti-pattern for a few reasons. Sending the request to many different tables can increase the backend connection overhead, resulting in increased tail latency. Having multiple tables of different sizes can disrupt the behind-the-scenes load balancing that makes Bigtable function well. Let's now look at the steps to create database on the Cloud SQL instance. Now, as the first step, you need to go to the Cloud SQL instance page in the Google Cloud Console. Then select the instance you want to add the database to. Next, select the database tab. Then you can click on Create Database. In the Create Database dialog, you need to specify the name of the database and optionally the character set and collation. Finally, click on the Create. Let's look at the steps to list your databases. First, you need to go to the Cloud SQL instances page in the Google Cloud Console. Then select the instance for which you want to list the database. Now click Databases. So a newly created instance has 3 system databases by default: Information Schema, MySQL, and a Performance Schema. The next thing is steps to delete a database. For this, first you need to go to the Cloud SQL instances page in the Google Cloud Console. Then you need to select the instance that contains the database you want to delete. Next, click Databases. Now in the database list, find the database you want to delete and finally click the trash can icon. Finally, in the Delete Database dialog box, you need to enter the name of the database as a confirmation, and then you need to hit the delete button. Now the next thing is choosing the data storage options based on the use case consideration, such as data volume. Here you can use Cloud Spanner storage capacity of petabytes, which ensures the load handling, and it is capable to store billions of data on a daily basis. Data access. Here you can use Cloud Memory Store, which is a low latency and it assists the high speed data access and data transfer. Choosing the data storage options are, the first one primarily is object storage. So it has cloud storage. It is the object storage for companies. You can store any type of data, any amount of data, and retrieve it as often as you would like. The second one is the block storage. It has persistent disk. It's a block storage service fully integrated with the Google Cloud products like the Google Cloud Compute Engine and the GKE. It can also have a local SSD. It is ephemeral, locally attached block storage for virtual machines and containers. The third one is archival storage. It has cloud storage and it has ultra low cost archival storage with an online access speeds. The fourth one is the file storage. It has file store. It is a fully managed service for file migration and storage. You can very easily mount the file shares on Compute Engine virtual machines. The fifth one is mobile app services. It includes cloud storage for Firebase. It is a scalable storage for user-generated content from your app.
For more details, check the link in the description. Learn with Whizlabs. Success certified.